All right, so let's look at this loop here. So this loop is going to create a field, and we're going to look at what the field is on the axis there. That's all we can do with what we've got. And how did we do this previously? Well, we said that for the loop, the field was E equals mu naught over 2 pi times m over r squared plus z squared to the 3 halves, which means we have to find the magnetic moment of the loop. That's really easy. M equals IA, right? In this case, I is 1 ampere, and A is pi times 0.05 meters, or 5 centimeters squared. Okay, and then we just have to multiply all that out. That's equal to, let's see, that's 25 pi times 10 to the, I'm looking at a minus 4. Is that what I'm looking at? 1, 2, minus 4. Times amps times meters squared, which is what we have, and that's about 78.5 times 10 to the minus 4 amps meters squared. So we find that moment first here, and after we find that moment, we can look at what the actual field is. Okay, so like I said, the field is going to be mu naught over 2 pi times m over r squared plus r squared over 3 halves. Let's see. That's because the total distance is this thing, right? We went through and we talked about how to figure out stuff based on this rotation, based on this symmetry here. So we know that the field is going this way, right? The magnetic field is going that way, because the horizontal part from this and the horizontal part from that cancel, or it gets vertical in this case. And so that gives us a field that looks like this, right? So you have a sort of flat area. It's actually very, very close. It's flat, but still it's very, 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 very little is happening right there around 0, because basically this is dominated by the radius of the loop. And then as we go down, and we're going to go down to about here, I think, right? So this is r over r, so we're going to go down to this spot, which will be 10 over 5, or 2. We get really, really close to the 1 over r cubed, so actually probably 5 centimeters would be best, because here we're not near either of these two limits. In this case, we're getting really, really close to that limit. And that's where these two lines hit, basically, that's where you can just pretend you have a physical dipole at a certain point and ignore the fact that the dipole is coming from the current loop. All right, so then we have mu naught, which is 4 pi times 10 to the minus 7 Tesla per amps per meter, over 2 pi times the moment, which we said was 78.5 3.5 times 10 to the minus 4 amps meters squared. So that's going to get rid of amps and one of those meters. No, it's not, is it? Yet? No, it's not, because this actually goes up, so we'll have amps squared. And still get rid of one of those meters. So, let's see. Then we need to do the fun stuff, which is, of course, putting all this stuff in this place where we're going to take the square root and then cube whatever we get. That's a lot of fun. So now what do we do with this? Okay, that gives me a 2. So I get rid of the 2 pi goes into 4 pi twice. I have 78.5. So that gives us something like 157 times 10 to the minus 11. No, I did get rid of that. Tesla meters cubed. Okay. Tesla over amps over meters times amps meters squared. So the amps did cancel, and this ended up with the meters cubed. Ouch. All right. So this is 0.01. So we have divided by 0.0125 meters squared to the 3 halves, which ends up being about 1.123 times 10 to the minus 6 Tesla. Okay, so that puts everything in there. Basically what I did was first I found the moment for the loop and took that moment and put it here into this equation and plugged a bunch of numbers in, did a lot of math, screwed up the units to figure out what the field was at that point, which is again really close to where the 1 over r cubed approximation works, where you start being able to ignore the fact that you have a physical dipole and that you have, and just pretend like it's a real, just pretend like it's a mathematical dipole, a pure dipole. Getting really, really close. So that's what I've got for this one. What's the next one? Next one is the next lecture. So we'll get on to that one, where we're doing just examples of different things, and then we'll go on to Unit 4. Bye now.